All right, so this video is going to be for pages 6 through 9 on your Kinematics 2 packet. So we're going to look at velocity versus time graph notes. Okay, so when we have a velocity versus time graph, okay, normally that's going to tell us our acceleration. It's going to look something like this. So you got to really pay attention. Your y-axis now is your velocity, and your x-axis is still your time. Okay, so if I want to find acceleration, acceleration is going to be your slope. So that's our change in y over our change in x. So change in y over change in x. Okay, so which would be your change in velocity. Your y would be your velocity. And your change in time, that would be your x. And that's going to equal your acceleration. Okay, when you go down here, acceleration, our equation is your change in velocity over change in time. Okay, so basically your v final minus your v initial over time. Now your acceleration for your units for acceleration, instead of writing something like this where it's meters per second over seconds, okay, we're just going to write meters per second squared. And the slope of our velocity versus time graph gives us, we just talked about that, that's going to be our acceleration. Okay, and then the next little dot is just basically stating, this pretty much Webster's dictionary of acceleration, is the rate of change in velocity. So how quickly are you changing your velocity? So if I have a couple scenarios just looking at basic acceleration, so I have something going up, we'll have a horizontal line and then going down. I would say that my acceleration is going to be positive on the way up here. Okay, now, because that basically means I'm increasing my velocity over time. So if you're increasing your velocity, that means you're speeding up, so you're accelerating. Now, if I have a horizontal line, that doesn't mean I'm not moving. It just means, let's just say my velocity over here was 5 meters per second. This just means I'm constantly going 5 meters per second. So my acceleration would be 0. Okay, then when I go the opposite way, okay, it doesn't mean that I'm turning around. It just means that now we're starting to slow down. So our acceleration is going to be negative. Okay, so it says, what would your acceleration be if velocity is constant? So remember, if velocity isn't changing, you're not accelerating. It's like cruise control on the highway. Okay, so that's going to be 0 meters per second squared. Now, a little bit of a summary on this. So the steeper the line on the graph, so we know our lines are acceleration. So the steeper it gets, the higher the acceleration. Okay, and I'm kind of abbreviating stuff to kind of save time. The flatter the line, okay, you're getting closer and closer to that horizontal flat line, that means your acceleration is going to go down. Now, a change in direction occurs when the v versus t graph crosses the x-axis. And we'll do a lot of graphing practice here in a second. But anytime you cross that x-axis, you go from a positive to a negative, that means you change directions. And the baseline where the velocity is 0 meters per second is called the x-axis. Okay, so there's kind of a key theme there. So we got to really pay attention to our x-axis when we do these graphs. Now, there's 8 types of motions, and I'll try to get through these quick. So you have at rest, that means you are not moving. So your velocity is going to be 0 meters per second. And your acceleration is going to be 0 meters per second squared. Okay, constant velocity forward. So I'm just going to write the abbreviations to save time on the video. In your notes on the key, it's going to be written out. So constant velocity forward, so basically CVF. Okay, so as long as you know what those mean, okay, so you don't have to necessarily memorize those, but instead of writing out that the entire time, because you will be asked what type of motion is going on, it's just a lot easier if you have these down. Okay, it's not really just memorizing acronyms for the sake of memorizing, it's explaining what's going on. Constant velocity forward means you have a constant velocity going forward. So CVF is just easier to write. So that means our velocity is going to be positive, okay, because you're going in a forward direction, and your acceleration is going to be 0, okay, because if you're going constant velocity, you're not accelerating or decelerating. Now, then the opposite of that would be constant velocity backwards, which means your velocity is going to be negative, and your acceleration is still going to be 0. Okay, so the key takeaway there is if you have a constant velocity, that would be like a horizontal line on a graph. Okay, it just means you're constantly going the same velocity the entire time and you're not accelerating. Okay, number 4 would be slowing down forward. So I'm just going to write SDF. Okay, that just means you're slowing down in the forward direction. So velocity is still going to be positive because you're going forward, but your acceleration is going to be negative. Okay, the reason why acceleration is negative is because it's going against the motion that you're trying to go. So like if you're in a car, you have a forward velocity and you pump the brakes, okay, your acceleration is not going to go with you. It's going to go against you to slow you down. It's going to decelerate you. So acceleration has to be negative. It's going to be the opposite. Then you have slowing down backwards. So slowing down backwards. So your velocity is going to be in the backward direction, so it's going to be negative. And now your acceleration is going to be positive. Okay, it's going to be the opposite. Okay, so when we're not slowing down, we're going to be speeding up. So speeding up forward, so SUF. Okay, so your velocity is going to be positive, and your acceleration is going to be positive as well, because if you're speeding up, acceleration is going with you in the same direction. Now, if you're speeding up backwards, so SUB, okay, your velocity is going to be negative, and your acceleration is going to be negative as well. And then number 8, your last one, which we're not going to talk about, we're going to have it has its own unit later on in the year, is going to be circular motion. Okay, so this is just to help explain what's going on in a graph. We're not going to give you a question where we basically say, list all 8 types. But when you get a graph, you got to really understand what's going on in the graph, and these acronyms just kind of make things quicker and easier to understand. Okay, so let's look at this graph. We have the x-axis is all highlighted here for a reason. Okay, so you've got to really pay attention to the x-axis. That would be my number one hint for reading a velocity versus time graph. Because if you're going towards it, that means you're slowing down. If you're going away from it, that means you're speeding up. Okay, if you're not doing anything, if you're just a horizontal line, that means you have a constant velocity. If you hit that x-axis, that means you stopped. And if you go through it, that means you turned around. Okay, so there's a lot to deal with that x-axis. That's why it's highlighted red. Okay, so for the sake of this graph, what I'm going to do is I'm going to go ahead and label the types of motion. So my first motion from 0 to 2 seconds would be a constant velocity forward. Okay, that just means I'm staying at 5 meters per second the entire time. Now, on this next part from 2 to 3, you got to be careful. I didn't turn around. I'm still going forward. Okay, I am just moving towards the 0 line. Okay, so this is going to be slowing down forward because I am approaching this 0 line. And anytime you're going towards 0, that means you're slowing down. Then at 3 seconds, it looks like I stopped. Okay, so I have no motion at 3 seconds. And then if you keep going, now I went through the line, I went through the x-axis, and I'm going away from 0 now. So if you're going away from 0, you got to be speeding up. But now, since you've dipped down into the negative, now you're going backwards. So this would be speeding up backwards, so SUB. Then it looks like we hit a constant velocity backwards, so we stay at -5 the entire time, okay, from 4 to 5 seconds. And now we're going back up towards 0. Okay, so that means I'm going to be slowing down, and I'm still in the negative, so this would be slowing down backwards. Then at 6 seconds, looks like we stop again. We keep going through, and we change our direction. And then we start speeding up forwards, because now we're going away from 0 again. Okay, then from 7 to 9, it looks like we have a constant velocity forward. And then from 9 to 10, we're going to be going back towards 0, so that's slowing down forward. Okay, so one of the things to take away from here is if you are above the x-axis, so above the x-axis, you are going forward or you have a positive direction. Okay, so if I asked you on this graph, when are you going in a positive, when do you have a positive direction? I would say 0 to 3 seconds and 6 to 10 seconds because you're above the x-axis. If you're below the x-axis, okay, that means you're going backwards or you have a negative direction. Okay, so if I asked you when are you going in a backwards direction or a negative direction, I would say from 3 to 6 seconds on this graph. Number 1, what is happening at 3 seconds? Well, that's when we hit 0, so that means we stopped. So velocity is going to be 0, and that means you also changed direction. Since we went right through it, we changed directions. What type of motion is occurring from 7 to 10 seconds? So from 7 to 9, we had a constant velocity forward. And then from 9 to 10, we had a slowing down forward. Number 3, what time interval or intervals is the object traveling with the greatest velocity? So this is where we gotta be careful. We're not looking for slope. Okay, so slope is acceleration. If you want to know greatest velocity, all you gotta do is look at your y-axis. Your y-axis is your velocity. So if I look, I'm looking for the highest values, whether it's positive or negative, it doesn't matter. So from 0 to 2 seconds, okay, I have a velocity of 5 meters per second. That's the highest I go in the positive direction. And then from 4 to 5 seconds, that is the highest velocity I go in the negative direction. Now, just because one is positive and one is negative does not mean that one's better than the other. It just means they're just different directions. So if I want to know when you were going the fastest, I would tell you both of the times. I would say 0 to 2, and then I would say 4 to 5, because they're both technically 5 meters per second, just opposite directions. Number 4, anytime, so a negative velocity means that you were traveling backwards. Okay, so anytime you are below the x-axis, you're going backwards. Anytime you're above, okay, then you're going to be going forwards. Okay, so let's look at the next one. On here we have A, B, C, and D. So we're going to go over types of motion, okay, our change in velocity, our change in time, and our acceleration. So line A, I'm going away from 0. And if you notice, our x-axis is along here on the bottom. Okay, so that means there's nothing going to be negative here. We didn't go backwards at all since we're all above the x-axis. So A is going away from 0, so that's going to be speeding up forward. Okay, so we're going away from 0. Our change in velocity, okay, change in velocity, so triangle just means change, would be your final velocity minus your initial velocity. So where did you end minus where did you start? Well, I ended at 20. And I started at 0 meters per second. So 20 minus 0 is going to give me a velocity of 20 meters per second. Now my change in time is just how long did it take. So look at your x-axis, that's going to be your time. It took us 4 seconds. And now A, okay, A stands for acceleration. Acceleration is change in V over change in T. And now I have both of those, so 20 divided by 4 is going to give me acceleration of 5 meters per second squared. Okay. Line B, looks like we stay at a constant 20 meters per second, so this is going to be constant velocity forward. Okay, what would my change in velocity be? So this is where you got to be careful. You ended at 20 and you started at 20. Okay, so your change in velocity is not 20. It would actually be 20 minus 20, which would be 0 meters per second. There was no change in velocity. And the time it took, we went from 4 to 7, so that's 3 seconds. So 0 divided by 3 is going to be 0 meters per second squared, which should make sense. If I have a flat line, okay, that means I'm going constantly 20, so that's like cruise control. I'm not accelerating or decelerating. Then C, looks like we're speeding up again. We're going away from 0, so SUF. Okay, my final velocity was 30, minus your initial velocity, which is 20. So 30 minus 20 gives you 10 meters per second. How long did it take? It looks like we went from 7 to 9 seconds, so that would be 2 seconds. So 10 divided by 2 is going to give me 5 meters per second squared. Then line D, so be careful with line D. We didn't turn around. Okay, we didn't change direction. We're still going forward, but now we're going back towards 0. If you're going towards 0, that means you're slowing down. So this would be slowing down forward. Okay, so what was your final velocity? This, you gotta be careful. Your final velocity was 0 because you went all the way down to the x-axis, minus your initial, which was 30, so negative 30 meters per second. That was your change in velocity. And then how long did it take? It looks like we started at 9, ended at 15, so that'd be 6 seconds. So negative 30 divided by 5 gives you a negative 5 meters per second squared. Okay, and that's going to end this video.